Hi, welcome to a special Geek Out edition of Subscribe. Subscribe is my video blog that I actually maintain over on channel9.msdn.com. It's a Microsoft technology blog. And this one is a little bit of an odd episode because it's about use cases that are enabled by cloud and not so much about how you do things in cloud. And this one is so interesting that I thought it would be better to have it not really in a geek corner as Channel 9 is, but on a broader channel. So I put this on YouTube here. And this is about automated driving or autonomous driving, which is obviously a very hot topic today. And our partner company, IAV, an automotive engineering company which builds driving assistance systems. So you might have technology from them in your car, even though you don't know. They have been on campus and have been showing off their autonomous vehicle to my team and some other teams. And I had the opportunity to go and ride with them. And so I will leave it to John Cooper from IAV to explain who IAV is, and then we're going to take a look at the vehicle and ride in it together. Enjoy.
IAV is a German-based automotive engineering consultant. We are 6,000 engineers worldwide, including a good bunch here in the United States where I'm based, but we work on a global basis like anybody in the automobile industry with OEMs all around the world.
And you make cars except if you don't make cars?
We make cars, yes. We are the guys who make cars run better, and our name never appears on the outside of the cars, but we can point to a number of cars and I can tell you I did this, we did this on this car and that on that car, and especially in the latest technology as well as powertrain engine controllers, but I'm in the driving assistance side.
Mm-hmm. So we have here a vehicle which is a Volkswagen Golf third generation, seventh generation, third generation, God. So what's special about this one?
Well, if you look at it, it's very hard to see anything unusual about it at all. It has the production camera on the front that came with it off the assembly line, and it also has the production front radar. The front radar is normally just used for automatic cruise control to keep a distance from the car in front of you. However, we've modified this car slightly. It's not easy to see, but this is a LiDAR, a laser radar scanner that provides other information. And because we do a lot of engineering benchmarks, we've installed another radar over here to this side, which is just allows us to compare the performance of these two competitive radars.
So for what we're going to do, the radar that matters is the one in the middle.
Is
right?
the one in the middle, yeah.
And that's the one that actually comes with this Golf as is.
And the Golf comes off the line with this radar doing one function and with the camera doing another function. Mm-hmm. So what we're doing is taking the data from these sensors and doing a fusion algorithm with it. And we can do it with not just two sensors, we can do 3, 4, 5, multiple sensors, ultrasonic, radar, LiDAR, camera, all of these. Bring them together to give us a surround world view of what is around the vehicle. Mm-hmm. We then are able to use some of our own control algorithms to control the lateral movement of the car and the longitudinal, lateral of course being the steering, mm-hmm. and steer by wire through the electric power steering, and the accelerator, the throttle by wire, and the brake by wire gives us the longitudinal changes.
So if I were going into the Volkswagen dealership and I was going to go and buy one of those, when I have that equipment, so that radar and the camera, what do they do in the stock function?
In the stock function, this will just keep the distance from the car in front of you.
So that's the cruise control thing?
The ACC, the automatic cruise control.
Okay.
All right. And the camera currently will tell you, hey, you're leaving the road. be careful, and we'll give you some guidance to get back in the lane depending on what level. Actually, the models that do that are not available yet in the States because Volkswagen lawyers are worried about this, but they're finally going to put some of these German options on the road here in the States.
Okay, great. So I think then we're going to go and look at the magic in the back.
Okay, great. Now, in the back end of the vehicle, we're going to show you a bunch of hardware. This hardware is used for the development test bed function of this vehicle. We don't need all of this to do automated driving. Automated driving really will have to be done in something like this, an electronic control unit, and this is something that we use for prototyping. But in order to allow my colleague who's going to be on to talk to you soon, easy access to the various sensors we can plug in and out of the vehicle, we have just separate wiring here to make this easier to access the CAN networks inside the vehicle. We have two PCs back here. We're only using 15% of a Core i7 to run the algorithms that we're doing for the data fusion. We then take that information and pass it to a micro auto box that gives us the translation into actual controls that control the lateral and longitudinal commands to the car. And then we have a translator, which in this case, because this is a Volkswagen, it speaks Volkswagen language, and it translates those commands into Volkswagen language. This allows us to be able to take this development platform and literally put it into another vehicle once we have the translation interface, and be able to do this and develop various algorithms on whomever's car with sensors coming from which other supplier. We are agnostic with respect to the choice of car and the choice of sensors. And that's what's a key part of our value add, is who is able to objectively give advice on what should be done.
I'm sitting in the back of this Volkswagen Golf now. There's a screen mounted to the passenger seats, the back of the passenger seat, which shows me what the sensor technology that's in the car is seeing. And you see that there's a lane that it detects, and now the lane kind of swerves around, and you see some objects that are floating around of us. So I'm going to go and turn to the front. And here's Lars, who's driving us. And is he actually driving us?
Yes. So currently, yes, but I'm able to activate the system right now while pressing one of my steering column buttons here. Mm-hmm. Then I have the ability to choose a certain speed, which is 60 miles per hour, and I'm able to increase my safety distance.
Okay.
And with this setup, so my foot is off the pedal, my hands are off the steering wheel, so the car is maintaining the driving task right now.
And it does that all by itself?
Yes. So it's using the camera and the radar inputs to detect the lane marks and to detect objects in front of us. And it's calculating a driving path and keeping us in the center of the lane. Mm-hmm. And as soon as there would be a vehicle in front of us, we would approach. The car would slow down to keep the safety distance, and of course to keep the speed in this case.
So in the middle here, there's a display.
Yes.
That has to do with this, right? So
what we show here is the current status of the surroundings. So the camera is detecting a solid line on the right, and is detecting a dashed line on the left, and it's offering me the opportunity to perform a lane change. Currently only to the left side, because it's by law not allowed to go on the right side. Mm-hmm. And yeah, so like in this case, where we forced to slow down because the traffic is somehow coming to a stop, I can use my turning indicator to maintain an automated lane change as soon as the camera would offer it to me.
But we're running into Friday's Seattle traffic. But the car is doing that. No, the car did brake itself, right?
Yes.
So, and from an experience perspective, what's currently happening that is slightly frightening because You know, this is the experience when you're sitting on the passenger seat and you're a little bit worried about the driver. That's kind of what it is right now, because you're like, go on the brakes.
So
And
this is all maintained by the car right now. So now I will reduce the speed because there was already a speed reduction on the sign, which is
and now
not
there's
yet
a truck
taken
that's
into
standing
account.
right there
And
and waiting.
yeah,
So we're
we're slowing down
pretty
again.
hard on the brakes, and the car just did that because drivers here, as you can see, have no problem with just standing right smack in the middle of the highway if they really want to go and turn. And again, we're being driven by, just at the right angle here. Just let you see it. The car kind of does all of it by itself and is following the road. So we're kind of in the road we're on is the 520 state road, which goes from Redmond over to Seattle towards the bridge, and this is kind of the one of the busier roads in the Puget Sound area. And so you just saw the traffic that's turning up north towards Everett,
And now
so
the car is offering again the ability to perform a lane change. So we have currently no back sensors mounted in this particular demo vehicle. So I will check in the mirror and towards the left side change is possible by just using the turning indicator. And yeah, so I'm able to have an automated lane change. But I also have the opportunity to always overtake the driving task. As you can see, there is a torque applied to the steering, of course, because we are in the corner. But I'm able to oversteer, and the car will give us the hint that it's now that I'm now responsible for driving. Same behavior. So I resume the system. Same behavior. As soon as I hit the brake, the functionality is dropped as well. Or even so, for example, the system now is activated again. As soon as I get rid of my seatbelt, the car is giving me the hint that it dropped the functionality. It is not braking because this could be dangerous with me not buckled up. So we have to exit here. So I'll do
so that we don't go on the toll bridge.
Which is nice. We did it yesterday already. So the view is gorgeous.
The view is the best view in the world, certainly. So we're going to go and turn around, and then we're going to go back on the highway. All right. So now we're on our way back to Redmond. Again, let me show you that screen again. So you see that the lane is detected, and that's kind of a picture of what we're seeing in terms of objects you see on the side and objects you see ahead of you. Right now, there's not a lot going on, and the individual lanes. We're currently driving on the HOV, the high occupancy lane. That's for people for cars with more than two people. So the sensor technology in here is using, as we initially discussed, stock sensors. Yes. And it's putting them all together. So the car is currently driving kind of all on its own. What is additional external information you could theoretically get, and what are the limits here in terms of automated highway driving?
So you can imagine that the onboard sensor set will always have a certain limitation towards the field of view or the range up to whatever 200 meters front and back. Not necessarily how many sensors you will add. It will keep within this distance. So of course it will be interesting and that it will be necessary to get additional information, for example, from vehicle to vehicle communication by Wi-Fi or vehicle to infrastructure information, so that the traffic light 600 meters in front of me is already able to tell me, okay, by the time you will arrive here, I'm red, so you can already start slowing down and save some fuel without having to brake hard just 50 meters in front of the traffic light, as well as, for example, Yeah, so emergency vehicles have the ability to send me the information that they approach from behind or approach from a right, and will be at the intersection in the same minute I will be in the intersection, so that there could be already communication above what the onboard sensor will be capable of. And of course, having this kind of multi-lane roads map information, and especially high definition map information, will be necessary to perform certain levels of automation as well. And if you imagine, even add more dynamic data, for example, the first 10 vehicles in front of me detected the speed limit sign 5 minutes ago, and will upload that to the cloud, and the cloud will be able to send me this information. I have another reliable information about the current speed limit, besides maybe my GPS information or my onboard camera detecting this speed sign.
And what's fairly fabulous is obviously that you can talk about those things and tell me them, and also gesture with your hands while you don't have them on the steering wheel. And however, right now, with the technology that we have right now that we're experiencing, you have to pay attention to the traffic, because as we saw, the car, when it doesn't know what to do, it's going to give the control back to you by beeping.
Yes.
So the next phase of what we're seeing here is effectively the immediate next phase of assistance systems, right?
Yes.
So then in the following phase, it's expected that the systems get so good that the car will anticipate when it gives control back to you, and all of a sudden you have like 10 seconds time to go and get back onto the wheel.
For example, there will be in a distant future or in the near future the situation where the car is capable of being its own fallback. So even in a situation where the driver is not reacting or not paying attention, the car needs to be able to perform a safe stop. And therefore, of course, you can imagine that the time will increase where the car is giving the driving task back to the driver. For example, telling me, okay, we will arrive the next exit in 1.4 miles. Please prepare that in 10 seconds you need to grab the steering wheel and go off that exit. And if I don't grab the steering wheel because I'm asleep, or I'm even worse, I'm dead or something, the car needs to be able to get, for example, on the right shoulder with flashing emergency lights, and say, okay, I'm not able to go any further because the driver has not responded yet. But imagine that I'm allowed to be out of the loop because the car is capable of doing that safe stop. You could imagine that I'd maybe like to use my time in a more efficient way, like just now monitor the car doing already my driving task. So I can imagine of whatever, answering my mails, or deal with my calendar, or start watching a movie or stuff like that.
And so with this instrument cluster here is a very traditional one, but if you imagine that if an instrument cluster like what you have in the Mercedes S-Class, which is just basically a huge set of OLED panels, then you could actually lean back and watch a movie. If the car can say, stops the movie, you have 10 seconds, you got to go and get back into it, then that becomes a feasible thing.
So from a safety point of view, I think it's even better to not deal with your smartphone and doing this, but use the onboard instrument cluster, because the car has even the ability to say, okay, driver, be aware, I have to shut down your application right now. I will show you back your instrument cluster because you have to fulfill the driving task. Yeah. So from the engagement of the driver, or getting him back to the driving task, it is even better solution than he's dealing with his laptop on his legs in this case. So getting really deeply integrated, not to just have a projection of the smartphone functionality, but really have that functionality, have the movie experience, and have the experience of checking email and checking whatever, Facebook and Twitter and all those things, right in the instrument cluster, using the display you have in your car in the front and possibly also in the back. That's obviously makes a lot of sense. And also because the car needs to interrupt your entertainment if it needs your attention as a driver. Yes, and especially handing over the functionality is also interesting, because as I showing right now, I have the ability to do weird gestures while just underline what I'm talking about.
Yes.
And it has to be ensured, of course, that the car is not misinterpreting that as the driver wants the driving task back, or the driver wants somehow the car to drive. So this is also an interesting part of the whole ecosystem, how the human machine interfacing will change.
Yeah. Well, thank you very much, gentlemen, both Lars and John. That was very interesting, and we've been driving autonomously all along, and now we're coming up on traffic. We're braking in an automated way, coming to a stop, and then also concludes our episode. Thank you for watching. Until next time, bye.